Hello, today I want to talk about a very interesting interview question that I failed to pass the first time I saw this question. This question is called custom power function, rather custom power function. Custom power takes in two parameters x and n, which calculates what's the result of x raised to the power of n. So when n is bigger than 0, custom power 2 to the power of 4, for example, you should time 2 by itself by 4 times based on this number, right? 2 times 2 times 2 times 2 equals to 16. When the exponent is 0, we return 1 no matter what's the value of x. And when n is smaller than 0, we push 1 as the numerator and 2 become the denominator. And minus 4 becomes 4, so half times half times half times half, we get 1 divided by 16 equals to 0.625. So let me just show you my solution, which failed to pass the exam. So, all right. So, custom power should take in x and n, right? So the first thing I check is edge cases. When n is equals to 0, I return 0. No, I return 1. And when n is smaller than 0, I did is I want to flip it so it met the condition of the first scenario. So I update x and make it equals to 1 divided by x and update n equals to minus n. So that I just need to return a recursive function, then I will have our result. So power, you can name it anything you want, x and n, first layer x and n, and let's write our function. So if, let's say, n is equals to 0, I should return 1, else I return x times the power of n, okay, x first, then n minus 1. Okay, so let's test my solution. So by the appearance of it, I have a correct solution and pretty intuitive one too, but it doesn't work if the number of value of n gets too big. The maximum stack will be exceeded. Okay, so let me show you what do I mean by that. So 2 to the power of 4. Okay, custom power function 16, and so by the look of it, it's all correct, but let me show you. So what if I have something like this? Maybe that not that big. Okay. As you can see, it's going to return me maximum call stack size exceeded. So apparently this is not working. And why is because I have called this recursive function too many times. So it's not supposed to be like this. Just to be clear, we need to squeeze it down for you know we need to update our recursion method and make it more time saving and more intelligent. So to understand that, we can say something like 2 to the power. Okay, how do I do that? 2 to the power of 4 is equals to 2 to the power of 2 times 2 to the power of 2 to the power of 2. So you get the idea. When the n is get the remainder when it's divided by 2 is equals to 0, we can break the value into two pieces, half times half. So we just, to get to this number, we just need this number, which will save us a lot of time. So we don't need to accumulate from uh, one by one and get to the our base case. So to do that, we just need to check this sign here equals to 0. If that's the case, we can declare another. So half equals to yep. And yeah, I think that's it. So let's run this question again. Almost immediately we get our solution. So that's the way to do it, which I missed. And let's just push it back to the base case. All right. So this can also be cleaned up a bit. Let me show you what I mean. So this is the solution one. Let's just keep it there and write another function down below. So function should be its custom function again. We could actually do something like this. Step 1 stay the same. When n equals to 0, return 1. Then let's just use this custom power as the original recursive function. So else, okay, if n is equals to 1, return x. If n is equals to -1, return 1 divided by x. If n 2 okay, then uh, I find this solution online, which I just saw. It's a very cool solution. It's on LeetCode. As you can see, I guess the same solution done. So the problem is that how compared to my original solution, and it's cleaned up because it didn't uh, sort of swap or flip the situation when n is smaller than 0. It just concluded in its overall algorithm. So the way it's being done is, let's take this as an example. So when the result is 2 to the power of -4, right? So I just, in here, as you can see, for example, when we have 2 to the power of -3 and n divided by 2 is not equals to 0, so it returns x times the custom power xn -1. So, for example, okay, let's just do the explanation here. So when we have this, this below algorithm will make it this. So in the end, the and when it's -4, n can be divided by 2, and it takes in a reminder of 0, and it just need to calculate 2 to the power of -2, and in the end, which the base case will return it x1, 1 divided by x. So the end result will be the answer of x times 1 divided by x times 1 divided by x times. Okay, so time to time 1/2 times 1/2 times 1/2 times 1/2. So as you can see, even if we start with this place, we can just minus it by 1, so we can get even number. Then we can still output the same result because these two will even out each other. So we will still be getting the correct answer here. So that's another way to clean up the code, something to keep in mind. And the cleanest way probably is just return x times n is also going to work, because we have JavaScript has relatively recently added this operator adapted from other programming languages, so we can also use it here. Great. So that's about it. That's how we can write a custom power function in JavaScript. I hope it's useful to you. Thank you for watching and have a nice day.